Problem 6. The Hamiltonian of a system with generalized coordinate and momentum. The Hamiltonian of a system with the generalized coordinate and momentum QP is H is equal to P square Q square. A solution of the Hamiltonian equation of motion. A solution of the Hamiltonian equation of motion is in the following: A, B are constant. Four options are given. A, P is equal to B e raised to minus 280. Q is equal to A by B e raised to 280. Option B, P is equal to A e raised to minus 280 and Q is equal to A by B e raised to minus 280. Option C is P is equal to A e raised to 80 and Q is equal to A by B e raised to minus 80. The fourth option is P is equal to 2A e raised to minus A square t and Q is equal to A by B e raised to A square t. Here the Hamiltonian is given. We have to find out the value of P and Q in terms of the constant A and B. First, let us write the Hamilton's equations. Hamilton's equation, that is Qk dot, that is equal to dou H by dou Pk. Then Pk dot is equal to minus dou H by dou Qk. These are the Hamilton's equations or Hamilton's canonical equations. In the given question, the Hamiltonian H, which is equal to P square Q square. In the question, the Hamiltonian H, which is equal to P square Q square. So from Hamilton's equation, we can write Q dot, that is equal to dou H by dou P, that is equal to 2P Q square. Similarly, P dot, that is equal to minus dou H by dou Q, that is minus 2Q dou H minus dou H by dou Q, that is equal to minus 2Q P square. These are the values of Q dot and P dot from the Hamilton's equation. Now, since Q dot is equal to 2pq square, since Q dot is equal to 2pq square and P dot is equal to minus 2qp square, we can write dq by dt. Q dot is nothing but dq by dt, that is equal to 2pq square, and dp by dt is equal to minus 2qp square. Now from these two equations, we can write dq by dt into dt by dp, which is equal to 2pq square divided by minus 2qp square, which is nothing but minus q by p, or dq by dp, which is equal to minus q by p. So we are arriving at this equation dq by dp which is equal to minus q by p. From this equation we can write dq by q which is equal to minus dp by p, and on integrating we have log q which is equal to log p minus log p plus a constant, let it be log a, or we can write it as log qp which is equal to a, log a, or qp is equal to a, qp which is equal to a. This is our first relation. Also we have dq by dt which is equal to 2p q square, dq by dt which is equal to 2p q square. Now substitute the value of p from the above equation. What is p? P is equal to a by q. Therefore dq by dt is equal to 2 a by q, q square, which is equal to 2aq, 2aq. Again we can write dq by q which is equal to 2a dt. Now on integrating we have ln q which is equal to 2at plus a constant, let it be log b, or ln q by b which is equal to 2at, or q is equal to b e raised to 2at. This is the expression for q. Q is equal to b e raised to 2at. Also we need an expression for p. For that use the equation qp which is equal to a. Use the equation qp which is equal to a. From that what is p? P is equal to a by q which is equal to a divided by b e raised to 2at, which is equal to a by b e raised to minus 2at.